Today we're going to learn about rational exponents. Rational exponents are exponents that are fraction. So if you remember from Algebra 1, the square root of 4 is 2, the cube root of 8 is 2, and the fourth root of 16 is 2. Well, another way we can write the exponents is what we call rational exponents. And the square root is 1/2. So the square root has an invisible 2, and there's a 1. So we can write this as 1/2. The cube root of 8, we can write it as 1/3. And the fourth root of 16, we can write it as 1/4. Okay. So the rule is, if we have a to the m minus a to the m over n, we can write this as the nth root of a times m. So notice that the denominator goes to the root. So in the first example, we want to write the following expression using rational notations. Rational notation is another way of saying write the expression or write the exponents with fractions. So as we look at a, we have the fourth root of 5. So that's the fourth root. So it's not a square, it's the fourth root. So the root always goes on the denominator. So when we write it, okay, this has an invisible 1, we're going to put the 4 in the denominator. So this becomes 5 to the 1/4. For b, we have the third root, the cube root of 11 to the second power. So the cube root of 11 to the second power. So the 3 is going to become the denominator of the fraction. So I'm going to have 11 to the 2/3. For the 7, so -3 is going to come down, and I'm going to write the 7 as a fraction. So I'm going to have -7 to the 5/7. So it's just another way of writing with rational exponents or radical notation. So example 2, we want to write it in radical notation. So what we're going to do is we're going to do the reverse. So the 3 is going to come to the cube root. So I'm going to write this as the cube root of 4, and then the 7 stays there. So the thing with radical notation is that we can write this two ways. We can either write it with the 7 inside the radical, or we can write it with the 7 outside the radical. Either one is the correct representation of 4 to the 7th third. For b, 5 to the 1/2, we're going to move this 2 to the radical. And notice that with the square root, we don't write a 2. It's kind of like the invisible 1. We understand that this is a square and this is the root 2. So we're not going to write a 2 here. So it's just the square root of 5. For c, the 5 is going to come to the root, so it's going to be the 5th root of -8 to the 4th. And remember that we can write this in two ways. We can either write with the 4 inside the radical or the 4 outside the radical. For example 3, we're going to rewrite the following expression using radical notation, and then we're going to evaluate. So first thing is we're going to write its radical notation. We're going to rewrite the 5 in the root. So I'm going to have the 5th root of 32 to the 4th power. So remember, I can write it either way. In these examples, it's easier to put the 4 on the outside to evaluate. So now what we need to do is we need to find what the 5th root of 32 is. What that means is that we're looking for 5 numbers that are exactly the same, that when I multiply them together, it gives me 32. So that number is going to be 2, because 2 times itself 5 times gives me 32. So the 5th root of 32 is just 2. And then I have to bring down the 4. So 2 to the 4th is 2 times itself 4 times. And that's going to be 16. For B, I'm going to write it as radical notation. So I'm going to move the 3 to this root. So what this means is that I'm looking for 3 numbers multiplied together that are exactly the same number, that when I multiply them, it gets me negative 125. So that's going to be negative 5, because negative 5 times negative 5 times negative 5 gives you negative 125. So the third root of negative 125 is negative 5. Then we still need to bring down the 2. So negative 5 2 is 25. So we're going to move the 3 to the radical to write it in radical notation. And notice I put the 4 on the outside. So what this means is I need 3 numbers that are exactly the same, that when I multiply them together, it gives me negative 27. And that's going to be negative 3. So the cube root of negative 27 is negative 3. And then I need to multiply negative 3 times itself 4 times. So the answer would be 81.